So in class, we started with the warm-up, and the warm-up was just to bring back to mind what a midpoint is. So if you have a point and you know that those two segments are congruent, then we would know that M is in the middle because it is AM is exactly the same size as MB. And so we set up number 1 and we had to factor it to solve it. And then 2, A and B were on a number line, M is in the middle because it's the midpoint. What you need to know is that it's halfway in between. So if A was at 4 and B was at 26, they are 22 units apart. Well, halfway would be 11 units. Now be really careful because what students will do is they'll say it's 11 units, but it should be 11 more than where it started. It started at 4, and 11 more than that would be at 15. Now, what happens, and what we're going to do today is what happens when these distances and these midpoints, when I want to know the lengths of them, when they're on a grid, when they're at a diagonal. It's not quite so straightforward. So we're going to look at some examples. So on your formula chart, you'll have a midpoint formula. The midpoint is a point. So it is an ordered pair with parentheses. Answer. And what you would do is you would add them together and you would divide by 2. So you would add your x values together and divide by 2, add your y values together and divide by 2, and that will give you the point that is in the middle. That can also be determined from the graph. We'll take a look at that. The distance formula, remember we had segment AB, would be actually talking about the actual drawing of the segment. But if you just had AB, what I'm asking for is the length. How long is AB, or what is the distance from A to B? Well, we use this distance formula, x2 minus x1 squared plus y2 minus y1 squared, and then take the square root of all of that. Now, that you can also use the graphical method. If you put those 2 points on a graph, which you're always welcome to grab some graph paper, then you can do Pythagorean theorem, which is familiar to you because that diagonal right here is the hypotenuse, that's your C. And you can do your horizontal change and your vertical change. That's actually where x squared or x2 minus x1 is your horizontal change, and then y2 minus y1 is your vertical change. And so that's where that a squared plus b squared equals c squared, right? If you were to take the square root of both sides, then c would be the square root of a squared plus b squared. And then this is your a and this is your b. And so those are the differences between your x values and your y values. So let's look at this on a graph. Find the midpoint and the length of segment AB if you have these 2 points using the graph. So using the graph, we just want to find the point is in the middle. So the point is in the middle. If you go all the way, if you check your slopes, right, if you draw in this triangle, you can see it's up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so it's over 10. Well, halfway would be up 3, so up 1, 2, 3, and then over 5, which would be halfway, 1, 2, 3, 4, 5. You can see that your midpoint is at 1, 1. So your midpoint would be at 1, 1. You can see that on the graph. One thing you can do is you can look and you can see if you can find the point and then just double check. Is it up 3 over 5, up 3 over 5? Yes, it works out. Now the distance, the length, well, we just found the 6 and the 10. If you remember, then you can use the Pythagorean theorem. So we can use 6 squared plus 10 squared is equal to c squared. So we have 36 plus 100 is 136. So 136 is equal to c squared. If you take the square root of 136, you get 11.66 or 11.7 if I were to round to the nearest tenth, 11.7. Okay, you can also, it depends on how the question is asked. You can also do this as a perfect square, leave it as a perfect square. The largest perfect square that goes into 136 is 4. So it becomes the square root of 4 because we took the square root of both sides, right? The square root of 4 and the square root of 34. Well, the square root of 4 is 2. The square root of 34 is a decimal that we don't want to use. And so you could also have that C is 2 root 34. So if it asks you to leave your answer in exact form, then that's how you would do it. Now, how would you use the formulas to find the midpoint? Well, we have our 2 points. And so what you're going to do is you're going to take your x values and put them together. You're going to add them. So I have already written the skeleton. Now I'm just going to have to plug them in, 3 and negative 7. Divided by 2. So when you do 3 plus negative 7, you get negative 4. Divided by 2 is negative 2. And then you have negative 2 and positive 9. So we're going to plug those in as my y values, negative 2 and positive 9. Negative 2 and positive 9 is 7, and 7 over 2. You can either leave it 7 over 2, or you could have negative 2, 3.5. 7 over 2 is 3.5, because if you were going to graph that, that's easier. 3.5 is easier to find on the graph. Now to find the length of the segment, CD, or the distance from C to D, again, I wrote the skeleton, everything except for the variables, and then you have x2 minus x1. It doesn't matter which one goes first, just once you pick, stay in that direction. So 3 minus a negative 7, and then negative 2 minus 9. Be careful. For whatever reason, people miss the signs. Even though you have the formulas in your hand, still people miss the signs, especially that plus in the middle. So I'm going to fix this double negative here. So keep that square root. So 3 plus 7 is 10, so that would be 10 squared, plus negative 2 minus 9 is negative 11 squared. Be very careful if you're going to do this on your calculator. It has to be typed in like that with parentheses. So then I have the square root of 10 squared is 100. The square negative 11 squared, be sure you type in with the negative also in parentheses, is 121. So it's the square root of 221, which is 14.86 or 14.9 approximately. You could also leave it in as a perfect square. Doing a quick check right here to see if I can figure out what would go into 221. Just off the top of my head, I can't find one real quick, so we would give you what we wanted you to round it to. Or you could leave it the square root of 221. Now, what happens when I give you the midpoint? So be sure you pay attention to what you were given. M is the midpoint. I gave you the midpoint. Now, I already drew this picture. Technically, this is on a grid, right? It would be on this grid, and it would be at a diagonal. But I think a problem like this is easier to see when it is not on a grid. Or we could look at it like this. So negative 1, 1, your M would be right there. E is located at negative 4, 6. So negative 4, positive 6, 1, 2, 3, 4, 5, 6. It's easier to do if you have grid paper. So that's E, and the question is, where is L? Well, L has to be down here somewhere. And so what you can do is you can put this on grid paper. You're always welcome to grab some. But I want to go from E to M, and that's halfway because M is in the middle. So I would do that same thing. So from E to M, I would go down 5, right? From 6. So I was at 6, and then I went to 1. So I went down 5. So I'm going to go from 1, I'm going to go down 5 more. So we have here, I went from 6 to 1. That was 5. Okay, and I'm going to go down 5 more. And if I go down 5 from 1, then I end up at negative 4. So I would be down here at negative 4. And then I went over from negative 4 to negative 1. So from negative 4 to negative 1, I went to the right 3. So I went plus 3. So I'm going to go another plus 3. Okay, from negative 1, I'm going to go over another 3. So I went over 1, 2, 3. That puts me at negative 1 plus 3 is positive 2. So the coordinates of L are at 2, negative 4. And I could test that out and see. So I think it's just as easy to look at it, like it just in a single dimension like this, compare your y values to get your y value, and then compare your x values to get your x value and go halfway. Okay, so pay attention though, that's going to sneak up on you. You'll try, what you'll do is you'll find the midpoint between M and E, but M is the midpoint, so you got to watch that in your questions. So number 4, write the equation of this in slope-intercept form. So this is a review of what we did the other day of the perpendicular bisector. So we got a couple of clues here. These are new. Of the segment if A is at -1, -2, and B is at 3, -4. So I went ahead and I found the slope. So here's what we have going on. Let's look at what this looks like. A is at -1, -2, and B is at 3, -4. Now, here's the line, or here's the segment that I have. I want the perpendicular bisector. So real quick, I'm just going to sketch it in to show you what it would look like. Perpendicular would mean that it's going to be at a 90-degree angle, and bisector means it's going to cut it in half. Well, in order to write the equation of that line, we need the slope of that line and a point that that line goes through. Well, that green line is passing through the midpoint of AB. And it has the original red line, AB, has a slope of -1/2. So my slope, that's the easiest thing to find now. My perpendicular slope is going to have the opposite reciprocal slope, so it's going to have a slope of 2. Now, what point does it go through? The point that it goes through is the midpoint of AB. So we need to find the midpoint. So -1 plus 3 over 2, and -2 plus -4 over 2. So -1 plus 3 is 2. 2 over 2 is 1. -2 plus -4 is -6. Over 2 is -3. And so my midpoint is at 1, -3. So that point right there is at 1, -3. So that's the point I'm going through, and I'm going through it at a slope of 2. We had to do all of that to be able to get to a point where we could write our equation. So now y minus y1, y minus -3, is equal to m times x minus x1. So now we're to that point, but you have to know what a perpendicular bisector is and how it affects this problem. So we distribute that 2, so we have 2x minus 2. And then we would subtract 3 from both sides and subtract 3. So the equation of that line would be y is equal to 2x minus 5. So if I were to go over here and graph it, if it was drawn to scale, it isn't, I didn't do probably very well, but it would pass through here at -5, and it would go up 2 over 1, and that's where it would cross. And so you could see that those two lines would be perpendicular to each other, and the blue line, the new line, would pass through the midpoint of a segment AB. Okay, so your midpoint formula, you add the x's together and divide by 2, you add the y's together and divide by 2, and you get a coordinate point. To find the distance, you can use Pythagorean theorem on your grid, or you can use the formula, take the difference between the x values and square it, add that to the squared value of the differences in your y's, and then take the square root of the whole thing.